thank you for spending your evening with Brighton Kotlin. For those of you who are new, Brighton Kotlin started in around, it was 2019 now. We had a few kind of really nice in-person meetups. Then obviously 2020 happened, and we kind of went a little bit dormant for a while. With the help of the team from Silicon Brighton, we've kind of kicked things into gear again in more of an online fashion. And we've had a few good online meetups. Last month, we had a really good session with Joe and Seb, and we've got a kind of a bumper lineup today. So 3 speakers today, as you can see. Hopefully you can see my screen. We've got Luca kicking us off in a few minutes. We've got Laksitha and then Raul. So really looking forward to these talks. Really looking forward to them. So, oops. Get this right. There we go. So Luca is Android engineer at Triller, and the title of the talk is Compose Your Trill. So then we have Laksitha, who's a lead engineer with a fresh look at coroutines, and Raul a bit later on, who will be talking to us about getting ready for declarative UIs with unidirectional data flow and using Kotlin coroutines. So really cool stuff. Steve, did you want to kind of do a bit about Silicon Brighton and kind of how you guys help meetups like Brighton Kotlin?
Yeah, that'd be great, Lee. Thanks a lot. As you went onto those slides there, I thought you might have missed me out. We've done so many events over the last couple of weeks that I'm almost getting a little bit bored of the sound of my own voice. But yeah, no, I just want to say just thanks, Lee, and hi, everyone. Yeah, really appreciate everyone joining us today. Laksitha, Luca, and Raul, when you get here, just awesome of you to come along and provide us with so much of your time. And yeah, we're really looking forward to this. Just to give you some background, any of you who are new to Silicon Brighton, we're a community-led initiative to support digital growth across the South Coast. We began sort of 18 months back now, feels like a lifetime, but really not that long ago, by working with local groups to help raise their profile and provide individuals, just like everyone here today, with free opportunities for networking, training, upskilling and development. And the aim is to try and help everyone benefit through the sharing of expertise and the forming of new partnerships and connections. So far, we've run and supported, I think it's pretty much, I'm not sure exactly how many, close to 100 events now, so I'll have to check back, but certainly well over 90, and we've given a platform to hundreds of speakers to share their knowledge. Just really hope everyone enjoys today's session, and I'd just like to say that we're really keen to hear from anyone watching who wants to explore how they can contribute to the project, whether that's speaking at an event, helping with a workshop, or even starting your own group. So if you head along to our website, it's siliconbrighton.com. From there, you can join our community hub and you can reach out to any of the team. And that's enough from me, I think. Thank you, Lee. Back to you.
Thanks, mate. So we've got a slide here, just a few kind of other events that Silicon Brighton kind of help out with. These are coming up, so make a note in your calendar. They're kind of like really interesting. I'm particularly interested in the Brian Gophers one. That's had some really nice sessions recently. We're kind of lucky. We've already got a speaker lined up for next month for Brighton Kotlin. So that's on the 22nd. And so save that date, scan the QR code. We are always on the lookout for people who want to do talks. So ping me a message on Meetup if you've got something that you think you'd like to talk about. That would be fantastic. Yeah, I think we should get cracking, really. Just to let you know that today will be recorded. We're recording as we speak. We will completely edit out all faces and things like that. So feel free to keep your cameras on. Sometimes it's nice for the speakers to kind of see real people and things like that. So we will kind of edit all of that out and we'll let you know when the videos are uploaded. So I think, Luca, you're up. So if you want to share, then by all means.
Thanks. Sure. All right, you should now be able to see my screen, hopefully.
Yep, it's looking good.
Perfect. So hello, everyone. Thanks for joining us today. I'm Luca Nicoletti, an Android engineer working at Triller, and today I'll be talking about Jetpack Compose and how we are exploring and implementing this new technology here at Triller. So let's compose our trill. I'll be talking about what is Jetpack Compose, what's needed to set up your environment to be able to use Jetpack Compose, the target we choose in our app to go with our first attempt at using this new technology, and then I'll show you some code to get a better understanding of how this new library is used. A disclaimer here, there will be quite a lot of code, and you might not understand it at first. I'll try my best to explain what's going on in the code, but feel free to take any note on the slide number you don't completely understand and ask for a question at the end of the session. In the end, I'll draw my conclusion and the ones of my company as well. Let's start with what is Jetpack Compose. Jetpack Compose, it's a modern UI toolkit provided by Google, used in the Android framework. It's entirely based on Kotlin. All the code in the libraries provided is in Kotlin. And this can be checked as they are developing Compose in the open. It's entirely open source. Jetpack Compose requires a paradigm switch to develop with it. It's not like using a new view class in your layouts. The way we define our screen in our apps changes drastically. And last but not least, it's completely decoupled from the operating system, which means that bug fixes and improvement can be rolled out without relying on a system version update. So as said, Jetpack Compose is entirely written in Kotlin. Also, Compose, it's not only a UI toolkit. There are actually two fundamental components in Compose. One is the Compose UI, the collection of all the libraries exposed from Google, which will allow you to define your views and screens. And the other one is the Compose compiler, which is what is hidden behind the scenes and allow us to use Jetpack Compose the way it's supposed to be used, without the necessity of writing too much code for ourselves. The main building block of Jetpack Compose is the composable annotation, and we'll see later how it's used. And think of this composable annotation as a keyword. It works almost like the suspend keyword in Kotlin. And here is where the Compose compiler comes in place and does its job. Using this annotation, you signal to the compiler that it needs to change the code we wrote. The composable annotation, as the suspend function, changes the signature of the function to which it is applied, changing the parameter list and the return type as well. This allowed the runtime to calculate and know which function of the composable ones needs to be retriggered and when during the app life cycle. This procedure of invoking the function when it's needed, it's called recomposition. So as said, the main concept of this new library is the composable annotation, which is to be used on function. As we'll see later on, our interview hierarchy will become just a function. And that's because the goal of Compose is to be functional. So pure and without any side effect. But is it like that already? Unfortunately, it's not. Side effects are still happening, even with this function-only approach, but they're working on moving towards a more pure solution. For example, they have already made all the parameters that the compiler is adding to your function read-only. Another key principle for Jetpack Compose are trailing lambdas, which allow specifying the last input parameter of a function in a fancy and eye-catching way, and we'll see later on how it's actually been done. So I told you about a paradigm shift that is required to start developing with Jetpack Compose. Jetpack Compose provides a declarative API. So the shift needed is from the imperative mindset that almost every Android developer has to a declarative one. Usually imperative and declarative are used side by side to give a better understanding of what changes between the two of them. If you think of a simple layout that has, say, a tower of 3 blocks, the imperative way requires you to lay down each block after the other, whereas a declarative way allows us to define a column or a tower with the 3 blocks. And as you can see from the slide as well, it's way leaner and cleaner how you actually define what you're willing to achieve. The imperative solution that we all know and we are using in Android nowadays comes with a tree of widget or views with an internal state. And we are allowed to manipulate this internal state with several functions that the framework provides, as set text, set visibility, add child, remove child, etc. And this can lead to having illegal states. What happens if you update a view with an inconsistent state from, say, 2 different points of your code, maybe 2 different classes as well? Maybe you set a text from a fragment on a view, and then as this fragment is bundled in an activity, from the activity you hide that view. What happens? Spoiler alert, the view is still invisible. So Jetpack Compose and any other declarative framework, such as Flutter, React, React Native, allow us to describe our UI right now, but for every value of now. And our code will be independent of the previous state. As we have a functional approach as well to declaring our views, we will have data going down from parents' view or components to children or to leaves in the tree, and events going up to avoid side effects inside our smaller component of the view hierarchy. So keep in mind that the smallest and leaner the component is, the less likely it will contain and hold a state for itself. A small note worth mentioning is that Jetpack Compose is still in beta. Its first release version is planned for this year, Google I/O, and right now it's quite stable and feature complete, but might contain bugs. This is the Google way to ask us to not ship production applications yet with this tool. So to use Jetpack Compose, the first thing to do is to download the preview release of Android Studio. The stable one does not contain the Compose compiler I told you about earlier, so you won't be able to work with Compose. You could actually use the stable version to write code and also to run your application. But without the compiler that will change the signature of the function, you might have unexpected crashes and behavior at runtime, which you don't want. So what you need to do is also update your build Gradle file, adding the 3 following things. So you need to set compose to true in the build feature. You need to target JVM 8, so Java 8 or Java 8 in the Kotlin option, and set use IR to true. The compose option, compose compiler version and compose extension version are as such. There is actually already an update, and the compiler extension version has reached 1.0.0 beta 9. I haven't updated the slide, sorry for that. And then, depending on what you're looking for to use, add all or just some of those libraries to your dependencies. For example, if you're not planning to use the integration with RX Java because you're not using it in your project, say you already migrated entirely to Coroutines, you can avoid that package. Or you could avoid the material and material icons if your app has a design system that is different from the material one, just to save some space in your bundles or APK if you're still shipping APKs. So now let's talk about our target and our app a bit. This is our age gating screen where we ask the user to provide his date of birth. At first, it seems to be a really simple screen, just a few labels, an input, a link, a button, and the navigation toolbar with a back button to navigate back. What's interesting here is how the edit text changes over time based on the state in which the screen is. So depending on the user input, this edit text changes how it's displayed to the user. I go through the code we had before, trying to migrate to Jetpack Compose first. It should be code that everyone is familiar with. A bunch of Kotlin lines, some checks, if statement, sums, carrying XML as well. So here is how we start everything. So from the activity on create callback, we're using view bindings. That's why we're setting the root container as a binding.root variable. Super on create actually usually calls the set content view on that root container. We have a base activity class which handles this for us. Then we set up the views. We observe these states and the events that are sent from the view model, and we also initialize the view model. When we observe the state of the view model, we react to the state based on which actual implementation we receive of the state, and we update the view accordingly. For example, here we have three types of state, three type of possible state: a loading, an error, and the user input. So when there is a loading, we just show a progress dialog. When there is an error, we show a message, which is a banner. And then the main thing is when the user is actually interacting with the edit text. So as you can see here, we update, we call our render function on a birth edit text widget, which is a widget we created. And then we providing all the values. So if the text, if it needs to show an error and if the date is valid. And then we enable or disable with alpha the button at the bottom of the screen. And this is the body of the render function for our widget. This is the only function that our widget exposes. So we already copied the idea of rendering the now from Compose for every now. And here we also use view bindings. And as you can see, there is a lot going on. For every single label, we show or hide it depending on the value received for that label. We change the input type of the edit text based on widget containing a password or not. We render an error if the error is not null, and we show and hide icons around based on other condition, sometimes more than once a time. This is the set text or hide function, just an extension function that checks if the text provided is not null, and if it's not, it's set into the text view and show the text view, otherwise it hides the view. And we also have two layouts, one from the activity, which bundles the navigation toolbar and the edit text widget and the button, and a slightly bigger and more complex one, which defines our edit text widget that comes with the heading message, notes, error message, icons, and input field. So this is all the code that we have that we had in place, which was not too bad, thanks to our widget system that we're using. We already in the mindset of using a declarative API, as you've seen, thanks to the render function, which is the only one exposed. And here the result done in Compose with just a few hours of work, not much. And it's a little bit different, as you can see. The navigation toolbar has a wrong color. The edit text doesn't display the blue border for the selected status, but that's because it's just a screenshot of the preview of that screen. I didn't say anything about it, but another cool thing about Jetpack Compose is that it allows you to see a preview of what you're building without actually running the app on a device. All you need to do is to annotate the function that you want to preview with the preview annotation. And there are some limitations though. For example, you cannot have the preview annotation on functions that have parameters without a default value. But you can tweak the preview. It's quite powerful right now, and asking for a specific device frame, specific size of the screen, specific DPI, and Android system version as well. So this is the code for the Compose. And again, where it all starts, it's inside the onCreate function of the activities. And it's a little bit different, as you can see. And what we're using, it's a composable function that is a new method, which is the set content, that allow us to provide another composable function inside of it to be rendered on the screen of that activity. So what we're doing here is setting a theme. And as this screen changes how it's displayed, so we basically have a dark and light theme for this screen based on some conditions that are provided through a parameter from the bundle of the activity. We're setting the light or dark theme inside the age gate, inside the Triller theme of Compose as well, just by this check. We then define a surface and set the background color to material theme colors.background, which is a property that is overridden by the Triller temp function and scope we're already in. And last, we call our composable function that defines our screen, age gating screen. And well, after setting the layout, we also initialize the view model. Note that we're not observing any state at this point. So this is the, sorry. This is the entire screen, and it's entirely described by a function now, which accepts a view model instance. And here I actually forced the dark theme just to take the screenshot to add it to the slides. It shouldn't be there. It should just be the column with the back arrow of top bar and the age gating screen body. And as you can see, we provide data from top to bottom. This is the back arrow of top bar, which actually uses the top up bar, which is a function provided by the framework, fixing its height to 64 dp and filling the width of it. And inside of it, again, using the trailing lambda, we just have an image and a resource with this helper function painter resource. We set content description and we tweak it a bit, adding some padding and making it clickable using the provided function from its parent in order to handle the click. The body itself, it's a little bit more complicated, but we'll go through it step by step. We first have the state saved through observer state, which is a helper function they provide that returns a live data wrapper around the state of that screen. And as we can see here, we can access the state value and the text, or for example, if the date is valid later on in the button. And so we have a column which creates some padding and fix the height of the entire screen. And the vertical arrangement of its children are space in between. So that's how I achieved to create all the space in between the two components. So the first child is another column that bundles the header, the body, the text field, and an annotated string. And then the second child is the button, which is at the bottom. And we'll go through every single header, body, text field, and other composable function that we define. This is the header. It just uses the text function, which is the equivalent of a text view for the current framework. And what we do here is just setting the font size, family, style, and weight. And we accept a modifier from the outside in order to be able to set padding or margin from the outside. And this inside is the body. It's basically the same thing, but what we do here, it's using a specific color for it, as otherwise every text by default uses the material.colors.on surface or on background, which is white by default and white on our theme as well. This is the text field, which is a little bit bigger, but not too big, to be honest. So what we do here, it's calling the text field, which is a function provided by the framework. We set the value and we provide the callback for the on value change. we set a placeholder, and then we start tweaking it a bit. We fix its height, and we give padding, filling the width. We then set the colors. For example, for the background, we have this gray scale for 100, and then the indicator are transparent, as the text field actually creates a line under the text field as a focus, unfocus, and disable indicator. So we can't rely on that by default. We need to tweak what we do. Then we gave it a shape as a rounded corner shape with a round corner of 8 dp, easy. And then we set the text style in order to have the same font and style and weight. The annotated privacy, the annotated text is longer, but it's shorter than using span builders are really used to. So what we do here is we gather the toString with another helper function, string resource, the enter one and the one to make clickable. We get the indexes, we add the enter string to the annotated string, and we then add the style in the correct position of the string, adding as well the annotation, which is an URL from start to end index. Well, it's now pointing to GitHub, just didn't want to showcase our link for the privacy policy. And then we call another, after building the annotated string, we call another composable function, which is the clickable annotated text, which it's just a simple wrapper around the clickable text, which comes from the framework. And as you can see, we give some padding, we provide the annotated string, and then we tweak the style. It's worth noting that the style that we define here inside the clickable text won't affect the one defined previously, which is the one that gives the color to the actual annotation of the string. And last component in this screen is the button, which uses the text button from the library again. And we also need to tweak the style, we change the colors, we give some elevation, we give it a shape in order to have the rounded corner, we fix the height and fill the width. And the button, it doesn't contain a text view anymore, as it's used to be in the view system right now, but it accepts whatever you want as the body of the button itself. And here we're just providing a text. And here again, we're just setting the color to white and tweaking the size in order to adhere to our styling. And that was it. That's all the code we had to do for the entire screen. And so in conclusion, is Jetpack Compose worth using yet? What's the speed of development compared to the standard and quote unquote older way? How fast is the learning curve? And what's required to have it approved in a company? Not all the companies allow developers to jump on board with new technology, especially if this technology are still not released in a stable version. And answering the previous question might help you push forward with the adoption of Jetpack Compose in your company. So in my opinion, it's totally worth it, for sure. It's a way better developer experience to write code in Kotlin and handle everything from there. All the layouts, views, screen are defined and maintained by function in Kotlin. It's way easier to work like that. And also, again, comes in place the representing the now of the state of the screen. And the speed of development really depends on what you're building. Let me explain. If you use the material design system, a lot of components are ready to use. You just need to call the correct composable function and you're good to go. If instead your design system differs a lot from the material one, you might need to use core components of Jetpack Compose. So for example, you might need to use, as we did, the edit text and not the outlined edit text that the material library provides. But this problem comes with the current Android UI system as well, right? Yes. So what's the difference? Well, the difference is that Jetpack Compose doesn't have, as yet, a community of developers using it 8 hours a day. So you might find a problem or something blocking you to achieve a given design for the first time around, and you might not find any solution at all on Stack Overflow or elsewhere. And this can slow down a lot the development speed. One thing that can speed up is that once you've built that single component as designed, you will be able to reuse it as much as you want in your entire app. So it's a build one, use everywhere approach that you provide. And the learning curve, it's the same. There is not yet enough material out there to speed your learning process as much as you want. So the learning phase will be more like dig your hands in the code and give it a try. And that was it. Here are some references from where I took the first section of the slide, alongside reusing some old slides of mine from previous talk about Jetpack Compose, and a nice library, GitHub library, that showcase a lot of Jetpack Compose elements and how to use and customize them. And this last one, it's from Airbnb, and it really helped me going through implementing that screen in a faster way. And now I'm sure I rushed over the time, so I guess we have a lot of time for the questions. Can you confirm if we have any time for the questions?
Yeah, we've got a few minutes. If anybody has any questions, either use the mic or put them in the chat. We've also put your contact details in the chat as well, Luca, so people can reach out if they think of something later. Quick question from me, actually. Do you think you'll kind of capitalize on your Compose knowledge and start thinking about kind of Compose for desktop and things like that at Triller, or is that not something that you guys would look into?
So for now, we're not looking at using Compose in any other way rather than Android. We are not, we don't have a Kotlin multi-platform project, so we won't be able to share Compose on desktop or web as for yet. And I don't think there are plans for the company. I mean, I can't say anything for the company by myself, but we don't have a desktop platform yet. So I don't think that there are any plan in the near future, at least, to do that.
Okay, awesome. Okay, I think unless anybody has any questions, then I think we're good to go. Really appreciate your time, Luca.
Thanks to you.
Great talk. Like I say, take a look at the chat for Luca's contact details. And
yeah, actually, I'll be posting the slides on Twitter as well as soon as we're done. So
perfect, great stuff. Thanks, mate. Really appreciate that. Okay, so now we have Laksitha with a fresh look at Kotlin coroutines. So
yeah, let me share my screen.
Like I say, feel free to add any questions in the chat as the talk progresses, and we'll kind of get them read out at the end if you don't fancy jumping on the mic and asking them yourself. So great stuff. Over to you, mate.
All right. So hi, everyone. Thanks so much for joining me today. Can you see my screen?
Yep, it's looking good.
Oh, brilliant. Okay. So yeah, let me introduce myself. I'm Laksitha. I'm a lead engineer, and I've been mainly working on backend development, especially around microservices and mostly on JVM. And yeah, last couple of years, actually, I got a really good chance to work on Kotlin, and I really loved doing Kotlin. And also today, I'm gonna look at one of those really nice features called Coroutines, which is a first-class feature in the language, and you can take that advantage of that without using the complicated library. And also for the backend development, Kotlin is getting more traction nowadays because, like Luca mentioned, and also Raul, you see that lots of Android world, it's not that new, but in backend, especially for microservices development type of projects, now people, developers try to adopt Kotlin. Right. So today's agenda is I'm gonna briefly talk about the concurrency versus parallelism, and also how usually a program, process, and threads work, and also coroutine as a kind of a general concept, and move into Kotlin coroutines. And I would show that how these Kotlin coroutines work internally and under the hood, and also one of my recent experience. And we hope that we get a few minutes for questions. All right. Okay, so quickly, I'm gonna lay the foundation about this concurrency versus parallelism, because why we need concurrency and why we need parallelism is mainly because we don't want to wait, do multiple things at the same time. But I'm sure this concurrency and parallelism come always together, and then sometimes people get confused. Why? What is the difference? So I quite liked what Rob Pike mentioned about concurrency and parallelism. So basically, concurrency is dealing with a lot of things, and parallelism is doing a lot of things at the same time. So that means for concurrency, we can do concurrent programming with single thread, but parallelism we can't do it in true parallelism. I mean, we have to have multiple threads and multiple processes, of course, running. So that means single thread concurrency you see in JavaScript or Node.js, it is event loop based concurrency, and parallelism is one way of doing concurrency, and another way is doing via coroutines. So the coroutine is also known as interleaved processing. So let's now move into coroutines. Actually, before that, I would like to again talk about quickly how usual computer program nowadays is not a disk but SSD. So you can see that programs are a set of instruction and loaded into the RAM, and then you see the processors are here, and inside the processor you see weekly threads. And that's an important part I want to highlight is there is always scheduler, and also you have context switches and preemption. Those type of heavyweight operations happen when you have threads, and that's why threads are people call they are expensive. They need always intervention. But threads are not bad or anything. I mean, I don't see that some of the challenges we see in the threads are also present in coroutines and higher abstractions level as well. But if you have done multi-threaded programming, you know that all these dangerous things and all the riskier bits like starvation, rest condition, deadlocks, all these nasty things which you have to deal with if you are not really expert on what you're doing. For these, the abstractions like futures, promises, actors, and also coroutines, basically they help developers with try to minimize this risk. So that's the benefit of all these abstractions. So you become more productive, developers become more efficient and easy to work with. So next, so now I'm going to talk about coroutines as a concept. Coroutines are mainly the lightweight cooperative construct that allow developers to be able to write concurrent code in sequential fashion. That's very important. The three words: lightweight, cooperative, and sequential, because they're not threads. So like I showed earlier, you don't have to have a OS schedule or something to schedule or handle coroutines. So because of that, you can create hundreds of thousands of coroutine in a single JVM thread or process. So also they're cooperative because coroutines run in a special block called coroutine scope. And also because of that, they know there's a parent and child relationship, and also they have a special way of communicating via channels, and also they are cooperative because coroutines get suspended and they can get resumed, and they normally give a chance to another coroutine, so another processing task. Because of that, you call them cooperative. What's the sequential code? The sequential code is like if you've done non-concurrent or multi-threaded program, you can reason the code very easily, because you write the code in instruction one by one, sequential fashion. But if you think about threaded threads, multiple threads, or if you want to use the callbacks or futures or promises, you become ugly. You have this callback here, or could become it up in like very complex, hard to read code. So that's why another benefit, for the readability and easy to debug, those type of things come with coroutines because of the way we sequentially organize the code. Like I mentioned, coroutines is not something new. It's very, it looks new feature and trendy feature, but it's been around for decades. And you see many languages nowadays, they have coroutines. Especially, I like the way Golang is doing coroutines, because you can see that it's a single, one keyword, and then you put the function in front of it, it becomes coroutine. Runtime handles most of the things. And the Kotlin, again, something close to some user-friendly constructs, like builders. So we can see that you can launch a coroutine here, and you can execute your business logic inside that coroutine scope. So that's just about coroutine as the concept. And now we are going to look at Kotlin coroutines. So taking what we just talk about, sequential and cooperative, and also lightweight attributes of coroutines. So they also, the key components of Kotlin coroutines. At the same time, it has clear exit and entry points. So the reason is, if you look at this code on the right-hand side, you see that usually in a coroutine code, you have this the blocking and non-blocking world. There's a bridge called run blocking coroutine builder. When you have that kind of function inside this run blocking builder, you see you can launch any number of coroutines, or you can do any other processing. But the thing is, they are confined most, and also they are they have a special parent and children kind of relationship. So that's a benefit. So they're like thread-like, so you can easily see that you can run 100,000 coroutines without being running out of memory. So that's very special. And so this is something that's probably one of the major advantages against usual vanilla threads. Okay, now we're going to talk about one of the most important points, which is how do Kotlin coroutines work under the hood? It is something I wasn't sure until recently, because normally we have this abstraction, nice API, and we can just keep coding. But if you look at how they work, it's basically they have three major points. One is called suspension points. The other one is called continuation, and we will have a state machine. So based on three concepts, this Kotlin coroutines achieve this cooperative multitasking. Just manage each other, and they don't get blocked, and they get suspended, but they get resumed later. This attribute, all these nice features come into life because of three main concepts. So on the right-hand side, you see this simple coroutine code. So you have the main method, and you have one suspension points at multiplied by 100 method, and another one at divide by 10, I think. So I just made this simple code to showcase this concept. So you see that these two are suspension points, and everything else is usual, non-suspendable functions or code. If you look at the same code in a way, which I mentioned earlier, we have suspension points now, and then how compiler knows when to suspend and when to resume, and also how compiler or the runtime actually keeps track of the things like variables, a temporary state, or state management. Basically, how does it do? So the basic idea is like that. When you meet a suspension point, like line number 3, anything before that up to this line 3, label at, let's say, label 0, and then if goes on, and then there's another suspension point at number 5, you see another label called label 1, and also the last one is label 2, which is usual print line. So the compiler knows, okay, I have to break this code down to 3 blocks, label them, and keep the labels. And how do we keep these labels? There's a special object called continuation injected into these methods. For example, if you see this multiply by 100, it takes only one parameter. But once it compiled, if you look at the decompiled code, you see that there's another parameter called continuation, which is the state tracking object. You use this to keep the result or any other runtime construct we want to efficiently and also correctly execute these coroutines. So let me show you that actually let me show the code which I so this is example code, I showed on the slide, but at the same time, I just decompiled this into a Java code. So you can see that it's very ugly and a long code, but this is a major thing I want to show is, if you look at one of these multiply by 100 code. So look what it did. It basically, it injected this continuation object. So the continuation object is, if you go on to the next slide, you can see it's an interface provided by Kotlin standard library. And also we have this method called resume with, because it knows it can resume the execution or maybe handle the error depending on the outcome. So that's one of the key points. So you have this continuation object, and then you pass this into the suspendable function, and you see there are switch cases which actually maintain the label. Depending on the label, you switch back and forth. Or maybe if there are default case, which is no label set, you can probably say it's not it invoked before resume. Likewise, you just nicely handle these states using these continuation objects and also other builder functions. Right, so then you just saw that the code it's not that readable. This is just decompiled code, but I wrote this pseudo code extracted from that actual Java code. So you see that the basic idea is like you have a label, and depending on the label, you just go to the right coroutine, and then you can come back to the another coroutine or give the queue a chance to run execute while the other coroutine is doing its heavyweight or slow processing. It's just based on the label you switch between these coroutines and also other runtime tasks. So the state machine, like I said, it's just something simplified version. It looks like this. So you have a clear entry point, and also you have a clear exit point, and then you normally set the state at the beginning. And if this multiply by 100 function takes a lot of time, it will get suspended. And then after a while, once it's completed, it comes back and then goes to the next stage. Let's say it set the label as level 2, and it will give a chance to divide by 10 async function to run, and then moves on by exiting here. Maybe we can say we are setting the label to the -1. So this is a kind of a state transition in a coroutine world. So now I would like to talk about one of the recent projects I worked on. So let's say we are going to build a conversation platform for the users who can basically ask about their orders, train times, or anything which is basically for customer services. So the idea is like if you bought something from John Lewis and if you want to see where your order is and whether you want to reschedule your delivery, those type of things nowadays you can talking to Alexa or maybe talking to Google Home. Those type of smart clients are capable of answering those type of queries if you integrate and if you provide right APIs and do the processing. So the system architecture is like this. This is like a very simplified version of it, and you see this NLP engine. It takes a text and then try to get the intent of the user. For example, if you say, "Where's my order?" So this NLP engine knows, okay, this user is asking about an order. So this is the order, and we try to query the order management system perhaps, and then try to get the state. And if you want to ask the delivery state, probably have to go to delivery tracking system. Likewise, all this backend processing happen. Once we know the result or the insight of the query, we will again pass it through the NLP engine and push to the client. Could be WhatsApp or Alexa or something like that. So where the coroutines come in, you can see this component called a coordinator. It is by nature, this application was fully asynchronous, because these channels are asynchronous. You don't have to wait. You can do everything pretty much asynchronously. So this asynchronous communication actually helps in a way where you can scale and you don't have to worry too much about the shared state. And also we adopted this. This was a monolith, and then we used this web framework called Vertex, and Vertex has this built-in coroutine support, which is a nice, fast, Netty-based web server. And the coordinator is the component which, when you get the events from order management system, delivery tracking system, or payment gateway, it keeps track of which event is this and then try to perform relevant task. So that was the idea. So I'm going to show you the code here, and you can see kind of a simplified version of event coordinator. For example, let's say we got a call from order management system because user asked for order status or something. And then when you get this order event, we look for, okay, what's the status? If it is a create one, we just perhaps go and handle the created event and wait asynchronously. And also, if it's a new order, we want to create a new delivery task, and then return the task ID and move this task ID to another stage. Likewise, there were a series of multiple steps, and there were like aggregations and waiting for different outcomes. So this coordinator was a very good example. When I designed this and I developed this, I came to mind that, okay, this is a coroutine is one of the good use case and good a way to simplify and make this code more readable. And it is actually one other thing is because of the we wanted to run these services in very lightweight EC2 VMs, and we wanted to keep things lightweight and cost effective. So that's actually helped as well, because Vertex in one hand is very lightweight, and it was a basically good framework. And on top of that, Kotlin coroutines actually complement this server. So actually, that's pretty much it in terms of the example and code. So I would really like to hear any questions or anything if you want to discuss anything. I think we have some few minutes.
Awesome, that's really cool. Thanks, mate. I'm just curious around kind of how you go about testing this stuff. Into coroutines in general, back-end coroutines, things like that. Does that kind of make it more complicated? Is it it easy to do?
It actually, that's a good question, because it actually does the testing a bit complicated. In terms of, it's a naive, or the simple way is just to, when you run the test, you can see that in Kotlin coroutine guide, they provide these test utils. Usually you have to do the testing inside the run blocking type of construct. So because if you do the run blocking, it always works, because it's almost like a non-asynchronous code. But testing, if you want to test like event passing, or maybe if you are using like channels, it's a bit hard. It can introduce flakiness, and at least on my use case, you were able to do that using a run blocking type of sequential testing approach. It wasn't that hard for that, at least that project. But I know there are there could be challenges due to in testing.
Awesome. So I've got one question. Should coroutines be used instead of threads futures?
Right, yeah. So yeah, I'll say that. I mean, coroutines is not like it doesn't really fix one of the major issues in threads, for example. It doesn't really prevent you from corrupted shared state, I would say. So in usual, if your language supports, and if you want to do lots of asynchronous processing, and if the data is quite immutable, I would recommend going with the coroutines, because it's more readable and it's very easy to easy to write the code against it, and you see more confident with the coroutine code rather than traditional threads or something. But futures and promises, again, if you think the coroutines, the way it tries to return values are quite similar to futures and promises, because if you look at this code again, this asynchronous construct here, especially in this one, if you want to return something, you need to have a deferred object. So this deferred object is basically something similar to a promise. I think if you have the right support, and if you have the language support, I would go with coroutines, because again, this maintainability and readability. I don't think there's anything we cannot achieve from threads, promises or futures. But again, about the maintainability and readability aspects, I would go with coroutines.
Awesome. Really appreciate that, mate. Thanks a lot. That was awesome. Again, I've put your contact details in the chat if anybody wants to kind of reach out. And thanks again. That was really cool.
Yeah, thank you. Yes, I will do.
Okay, so moving swiftly on. Next up, we have Raul from as a senior software engineer at Twitter with a presentation called Getting Ready for Declarative UIs with Unidirectional Data Flow using Kotlin Coroutines. Hi, Raul.
Hello, Lee. How are you?
Really, really good. Like, really, really good. Really appreciate you taking the time to kind of come on and do this talk, especially as it's kind of one of the kind of last few talks that you're going to be doing for a little while. So I'm glad that we managed to grab you before you stopped. I'll leave the floor open to you.
Thank you. Okay, gonna share my screen first of all. Right. Hopefully Perfect. You can see everything fine. Yep. And let's start the talk. Cool. So yeah, as Lee mentioned, I'm gonna talk today about getting ready for declarative UIs with Unidirectional Data Flow by using Kotlin coroutines. And first of all, yeah, let me introduce myself. I am Raul. I work at Twitter for the last 3 years and a bit, working as a software engineer, working in multiple feature teams. And yeah, you want to follow me, I write sometimes some articles about coroutines, about Lily, Jetpack Compose, and Declarative UIs. So you will see anything that I write right there. And also, you are keen in seeing any code snippets from this presentation. Also, you can go to this GitHub user, which basically you will find everything in Git more than GitHub, because I don't have a monorepo for that, but code snippets are there for you. Cool. So let's go to the agenda very quickly. I will start with a use case where everything hopefully will make sense to you. Then I'll start analyzing the system architecture of this use case. I'll start also adopting unidirectional data flow. And I will make sure that the point for me here is like, it doesn't really matter which architecture for your mobile application you use. You can still use unidirectional data flow, and that's the point. And then some implementation details, some lessons learned, which is probably for me the most interesting bit of this presentation, and why Compose can be a choice that matters to us on Android, specifically talking about. And finally, we have some next steps. Then also that's something we'll see. But let's see, first of all, this use case, which is basically this kind of sample app with a search engine from the Twitter API. As you can see, I have a few states right there for the UI, which basically starts with a loading spinner, some list of results, as you can see right there. And basically the user starts just typing any query of interest. And then we can see, first of all, I fail after the spinner. So we have this empty results text with this not being found. And when finally is working fine, I have some results. And then we can see the detail of this particular item. And if there is any problem, any error, then we can see and show this to we can render this to the user basically. So that's the basic use case. Then let's see what architecture I started analyzing right there. And for that, then we can start from this point, adopting this from this architecture. Obviously, because this can be actually any architecture that you can think initially. First of all, I use a separation of concerns. So I had the data layer with the repository managing two different data sources, the network and the database data source. Then the business layer, combining end results coming from the repository. This use case is requesting these results to the repository, getting the results back, and then getting those to the use case, transforming this use case, anything that is going on, and then passing this back by means of a callback initially. And then I am connecting this area, which is the main architecture area, with the presenter, which is the main responsible of the presentation layer. And basically, this is executing the use case. And from this point, everything starts. And in the old times, for clean architecture, we use callbacks all the way down from the use case to the presenter and so on, arriving to the view. As you can see, the presenter is written in Java, but the use case is in Kotlin. This is also interesting to be noted because, as you can see here, the view is connected with the presenter, and then the view is also written in Java. So we are talking here about a hybrid kind of application which combines Kotlin and Java files. And then the view receives the new data and renders anything that it needs. The user intention basically is starting typing a query of interest. And then I extracted any logic from the view. Then the view delegate starts the query. And then the mechanism starts. And reacting to those queries, we are having this system interaction. Then I see a few coroutines that I use over here in the different entities. For instance, into the data sources, I use suspend functions that return some results to the repository. Then the repository is emitting a flow that is passing also the results back to the next layer. For me, flow here is interesting because by using flow, I make sure that I can emit more than one value. On the other hand, suspend function only return one sort of operation. That's one particular value. And that's why the repository is going to be the one emitting different values for that. Then the use case going to transform anything that comes from the other inner layers and then collecting the results back to emit or expose these to the other entities like the presenter. And that's basically it. But then how to get ready for declarative UIs? That's the main question we are trying to solve today. So first of all, you remember I say like I am using callbacks right there, but first question is, do we need callbacks or not really? Because if we are good with the callbacks, then why to do any effort to change and migrate those, right? So for that, we need to solve this question. Do we have any disadvantages on callbacks? So here we have our first guest of the night, that's Ryu from Street Fighter. Maybe if you're a bit old like myself, you can remember that. So he's doing a Yuken, and you can see that this Yuken from Ryu is creating a massive indentation. So basically, those are callbacks into callbacks, and those callbacks into more callbacks, producing a massive indentation that probably you cannot really read very, very good. And at this point, you created with Ryu, our guest, some callback hell. So basically, the problem here is, first of all, lack of readability. Second, if you have any problem here and you want to debug and fix the problem, you're going to have a very bad time to do that. So not ideal. Then also, the callbacks break a really interesting principle coming from functional programming, which is called reference transparency. This actually is the ability to make larger functions out of smaller ones through composition and produce always the same output for a given input. Very simple terms, if you are not familiar with functional programming, if you have a function and you have expected for a parameter, let's say you have a 3 as an input parameter, you expect always a 6 for this 3, and you change this 3 for another value. Let's say you have a 4 and you expect then instead of a 6, a 7, always gonna be 3, 6, 4, 7. If you change those values, that means that you no longer have reference transparency working for you. And this is something that we want to keep here. The fact that we have a particular output always being there for a particular input. So do we have any consequences of breaking referential transparency? Yep. If we think in callbacks, we don't have a return value. That's the first of all. Second, callbacks use all other callbacks as an input parameter. So that means that when we go to the next callback, we need the previous callback to have something to pass as an input parameter. So this doesn't really make sense if we think in making this principle working for us, because we don't have something that is deterministic. So that means that actually at some point results can mutate, and if they do, then you can tell me how you can make sure that you are tracking this problem and you can solve it. So we have actually a lack of determinism. We cannot really predict what is going to happen from an input, basically receiving this and creating an output. So that's not happening. Are there any better alternatives to callbacks? So I will say, if we think in Kotlin, we could use, for instance, Stateful, that is always returning the latest value when it's any different. And also return those results coming from Stateful are immutable. And that means that Stateful, because it's the contract of the Stateful, is read-only. You only have getters. You cannot change the Stateful when you are creating this instance for the Stateful. Right? And this also proves that Stateful is deterministic by default, which means that if you want to produce a Stateful and you have already this instance created, when you are collecting the value of the Stateful, it's not going to be mutated. So you have different entities in between. If you have different layers, you emit one value here, point A, and you're going to collect in point C, going to be the same one. So this is going to be deterministic by default. And that means that actually we can just change those things that we have over there, and the implementation for me going to be just switching between the callbacks and creating those Statefuls instead of those. Nothing else. But also, important thing to notice here, you have hybrid applications like I have. You need to collect the Stateful because it's a coroutine in a sense. So that means that you need to collect this from another Kotlin file, because you cannot really collect any coroutine with a coroutine context into a Java file. You need a Kotlin file for it. Now let's adopt unidirectional data flow. And for that, we need to think, what's that? What does mean unidirectional data flow? Because that means like, what exactly? This is it. Now it's data flow. We have one only way to start, and we have one only way to finish. So this also gives us the concept of determinism. We start from one point, we finish to another point, and that should be all. Right? Something like we have a UI, we intend an action, we transform those results from the action into a state, and this state is rendered as a UI. So that means that we're going to start again from the UI, intending this action, transforming the results into a state, and then rendering a new UI. So all the time going to be the same, starting from the UI and finishing into the UI. One state, one UI. If you want to produce a new UI, you need a new state. And with that, you're going to make sure that the UI is always representing a state. If you are processing all different states and you are ready for states, you are ready to represent different UIs, and that meaning rendering different UIs as well. Right? If we are thinking in creating those into classes, for instance, I just started from my imperative UI, intending an action, so triggering the view delegate, that is a delegate of the view, triggering those actions to the presenter is executing the use case. Let's assume the use case gets the proper data from the data layers. Then we dispatch this state once the use case is handling and managing and modeling this state for the UI. And then the stateful handler is communicating the state to the imperative UI, and then rendering this into the imperative UI. That's the first step. And that means that we can actually make sure that imperative and the declarative UIs can coexist. We can start playing with the different imperative UIs as they will with declarative UIs. Basically, we do that. We make sure that we can just switch and change the imperative UI with a declarative UI, as simple as that. That will make everything ready for Compose in that case. So advantages of that, flexibility, because if we change one imperative UI with a declarative UI, you're going to have everything ready to switch them back if you have a problem. You need to fall back to the previous implementation. You have now your system ready to do one or one another. Also, layers composition. If you create small entities to process different things along the way, you can just switch the different things that you have there and creating by means of composition over inheritance. Let's see some implementation details for that particular case. So first of all, if you think about it, I use data sources with the network and the database. So what I use, if you remember, were suspend functions. Once the operation returning some results from the network or the database. So something as simple as that. I use here dependency injection by having the Twitter API. That is just a client for getting some responses, something to check if there is internet, something to manipulate the different requests and responses. And then the function that I have right there is just a search function. That is a suspend function, no blocking, and also going to be authenticated and passing a query of interest. And then I will process that. And I will return those values with an operator called either. Either comes from the Arrow library, which is a functional programming library. In the left side, for this either operator, I have, if I have any problem, let's say a throwable or an exception. And in the right side, the successful result. That means a list of tweets that I'm expecting to have. Either is actually very similar to calling result. So if you're familiar with call result, this is essentially the same. Then if I want to do the same with the databases, the DAO for me is this. I am using here the room library. You could use something else, of course. And I'm getting the results in a descending order to pass from those tweets IDs and then retrieving that and getting those list of tweets that I'm going to use later into my query. Then the repository, going to use suspend functions and flows. So you remember, I'm going to return those results back to the repository, and then we're going to start emitting different values for the flow. The repository contains the data source for the network that we already know, different tables from our DB, and a few things there, some mappers, some combination of tweets and query at the token, and so on and so forth. And something called task threading that I use just to wrap the different dispatchers. Then the functionality, going to return a flow that is a list of tweets by passing as an input with IDs. They're going to pass the list of strings that are there. Right, and now we have different possibilities. If we think what we need, let's say we have this spam function, and then I have inside a functionality returning a flow. Is that even possible? Can I return a flow inside as a spam function? So I would say no, this is not really something you want to do, it won't compile either, because suspend functions, if you think about them, they need another suspend function to be able to run, or they need to be inside a coroutine context or scope. So you can just simply change that and use another suspend function inside, and that can be right. You can just return a list of tweets into a suspend function, and this will work nicely. Then this is as simple as just returning this with the suspend function, and that should be it. Then let's see a different case for the flow. Let's say we have a flow builder that is going to emit different values. If we have the operator emit all, that's going to work, because this one is going to emit all the values that the DB has observed, and going to emit all the values from this open stream. And this is a good example if we think in a poll, when we are refreshing maybe every 30 seconds with a background call to the backend, and you want to refresh the UI with the results. If you have an open stream, you can refresh the UI anytime that you have a new result. Then the flow on operator going to be the one responsible of making sure that the block for the flow is using the IO dispatcher, input-output dispatcher for our coroutines. Then this is also valid. We could use the flow builder with a one single emission. That means a suspend function there as well. Another possibility is emitting, first of all, the values that we have for the dirty values from the DB. And then if we refresh those values from the network, we can emit again. So we return this flow with a list of tweets. And now let's see for the use case overview what we have. So we're going to collect the flows. The flow is going to be passed, firstly, with the callbacks. And now the use case. With implementation of the callback is a use case with a callback as a parameter. We have the tweet repository and then the coroutine scope. And the scope that they use is basically a UI dispatcher with a supervisor job. And why a supervisor job? The answer is here, to avoid side effects on cancellation. Because in my case, I can have more than one thing behind the scenes. So what I prefer is to use a scope plus a supervisor job. That means to avoid other students' cancellation. Just to see that visually, let's say we have the scope plus a supervisor job, and I cancel job one, or maybe better said, job one throws an exception. Maybe you don't want to cancel job 2 and job 3, but you have scope plus a job. Then if job 1 throws an exception, job 2 and job 3 going to be canceled automatically. Maybe you don't want to have that because you have some processes that you want to keep when this situation happens. That's why I kept the scope plus a supervisor job. Right, use case implementation. First of all, I introduced the use case with the execute method, passing the query parameter, that's a string, and the callback. And then the cancellation method, if I want to cancel the scope. The execute method is going to start the callback initially, so showing the loader, the indicator, and then starting the scope with the launch. The repository is going to search for this query of interest, and then I'll map any operation if I want to do any particular computation that the business logic requires. And this means that I'm going to use this into the computation dispatcher, because obviously I don't want to block the main thread of the application. And for that, we can use flow on again. Flow on is an upstream operator. That means that anything you have at the top of it going to be into this computation dispatcher, including the map. Then catch, going to catch any problems that we have over there, any exception, and then collect, going to be the one for any particular stream that we are iterating to, passing those results to the new callback. That's what I have at the time. I can change and I can use launch in instead of launch from the scope. And this is a very nice operator because it's super convenient. You see, on each is basically replacing collect, and launching is replacing launch. The different thing here, apart from the syntax, is the fact that catch, because it's also upstream, gonna catch any problems that the on each operator gonna have. So you want to catch any exception there, you will have it here as well. And then I will cancel at some point my particular scope. So here we are. Now let's see how we can synchronize with the UI. So the use case with the flow, we are collecting things and we are passing back those things to by means of the Stateful to the different entities until we arrive to the view. So basically we are replacing all the callbacks all the way down to the view. basically we remove this use case that is a bit legacy, and we create a new one. And basically we remove the callback. We don't need this anymore. And I'm gonna pass this Stateful that's gonna be shared across the different stakeholders. Unused Stateful can be passed across Java and Kotlin files. So you can use it safely into Java files as well. So the use case flow, gonna use a tweets UI state that is a state for my UI. I'm gonna pass this dimension of get state flow, and I'm gonna rely into the state flow, which gonna make sure that the state flow is read only, because state flow is the interface that is getting just getters. And then for instantiating that from my use case, I'm gonna start initializing this instance of a state flow by using mutable state flow, and then I will expose this what means of the state flow. State flow is an interesting basically entity, because also has by default distinct altitude change. So basically, if you have different states, it will produce an emission of the value. But if you emit something that was already emitted before, then this altitude change will stop there and won't emit this value. So you have to take care about it. Also, you need always to pass the latest value. That means you always have one value, at least one. So you better have something for the very initial state, despite it's an idle state that doesn't do anything, but you need it. Then I modulated that for the UI with tweets UI state by creating a data class that is a list results UI state with a combination of tweets. And this is very important, because distinct altitude change only will have any effect if you use val. Why val? Because val means that is with only or immutable. If you have var, there is no way that either compose or the distinct altitude change of the state flow will recognize that this will change, because you didn't pass anything mutable. So you need to pass something immutable for this to recognize that is actually there is a change there. So yeah, better do it. Also, error UI state gonna be the same, passing a message and show this message to the user in the way that we want. For the empty UI state, something similar to that. We're gonna just say, hey, there are no results for this query, unlike you. For the loading UI state, we want to show something to the user. So basically the spinner or whatever you want to show. No message right here. That's why it's an object. And the same with the idle UI state. Maybe we don't want to show anything and just put some message, some initial message. Now we're going to start removing the callbacks. So basically the search tweet, we're going to search for the query. And we'll start the onStar operator from flow, which is very convenient as well. We're going to pass the state flow by means of the value functionality of the loading UI state. That's going to be the first step that we're going to start every time that the flow starts. And then for any iteration of this flow, we'll check if we have any results. If it's empty, then we'll pass this. And if it's not empty, we'll pass different tweets. As simple as that. And then the catch will pass the error from the message and will be shared across. Here we are. So we have this all the way down from the use case to the presenter to the view delegate to the state flow handler, and now we need to collect it. So to connect those different entities, basically the presenter contains the use case, and the presenter also executes the use case. So basically I don't need the callback anymore. We can get rid of this code that is already deprecated. And as you can see here, this is a Java file. So I am exposing this state flow to the next entity. I mean, so this function get state flow. Now the view delegate is going to do exactly the same. It's connected with the presenter and is exposing this to the next entity to work with. And in this case, I use a fragment from my UI, but you could use an activity, you can use a custom view, whatever you prefer. And I injected here a view delegate and the state handler and the state flow for us to handle those different state flows. And every time that I create the view, I start initializing the different flows and the views. So basically initializing this into my entity, and then collecting things by means of this state handler. Every time that there is an iteration into my flow, that means the state flow, I'm going to handle the UI states for me to render anything that is valuable for me. of course, into a scope because we need to collect it. That's why we need a Kotlin file. And now let's see a few cases. Imperative stateful UI rendering. Why stateful? Because imperative UIs need to handle a state. And we'll see why that means really. So we have the use case that is dispatching the state, stateful handler is communicating the state, and the imperative UI is rendering that state, right? So far, so good, nothing really complicated. So handle those states, this is a extension function that I am passing this state for the UI inside those. And I am, first of all, processing this list results UI state. So I created another extension function that is show results by passing that collection of tweets. And this one has a few other functions. Let's say, first of all, we have a loading spinner, this one that is indicating to the user that something is being loaded. And that is visible now, but we want to show the results. So maybe we don't want to show the loading data spinner. So we need to hide it. That's the first state we need to manipulate. Second state, have an error message. Maybe it was visible as well. So you need to hide it. And now you want to show the results. So you need to make visible this recycler view with those elements that you come into your recycler view with the different things and items. Then finally, you need to also pass the tweets that you had passed by means of the state handler, containing into the state flow this UI state and passing into that a collection of tweets that are going to be reflected into the adapter with the view holders. One tweet, one view holder. So that means that we are updating this adapter as well. A few things here. So we are manipulating a few states and a few widgets for our UI. Right. Now we have the other states that we need to also handle. So I created a few more extension functions, and I won't tell the different details for these implementation ones, but basically you can imagine if I show the loading, I will show the loading and I will hide the other elements. For the next one, I will show the empty state and I will hide the other elements. I will show the error and I will hide the other ones, right? And for the idle, I don't need anything for my imperative UI. I just make nothing there, right? So let's see what's the difference between that and the declarative stateless UI migration. Stateless because declarative UIs don't care about state. They care about rules and making the rules visible for you. And that means, having a contract. And then that means stateful handler dispatches a collected state, rendering those declarative UIs and making those ready for you. First of all, I created an entity called search composable UI, apart from the delegate and the handler. And first thing we need is into our XMLs with the layouts on Android. For interoperability purposes, you need to, first of all, add the compose view. They're going to be the one that you will use to start migrating. You will need an ID for this compose view that you will use in a moment. Like that. Into this particular fragment, I will find this view. I will get the compose view. And then I will pass the compose view to use it when I need it into my search composable UI that I created. Something like that. I will use assign this value and I will use later on. Right. Initializing flows with the view delegate with the state flow, and then when we get the state flow, we'll pass this search composable UI and we'll use that when we need it. So search state handler, gonna use the search composable UI and the state flow. Again, this is just initializing things into my state handler and processing the different states for the collection. So when we are processing those, equivalent to the previous implementation that you saw, but now I am using search composable UI for start composing my views with the US state. So I initialize this into that as well. I get the compose view reference for the content. And now we're gonna start playing with it and where the magic starts. So the compose view, we're gonna start setting the content, and the first thing you need is a theme. Now we need to think a little bit about coroutines because this is done in a way that is very similar to coroutines. Why is that? Because if you remember, coroutines and suspend functions in particular need to run inside another suspend function or a coroutine context. Likewise, we need a theme to be the first of the tree, And from that point, starting to build our composables. So initially you have a material theme, that's the default one. Preferably you want to have your own theme with your own colors and different things. That's why I create my own tweets with search theme. So yeah, let's assume we have the material theme that is our custom one ready. And now we can start creating different composables using states UI and passing the UI state. Now we'll start with the state and doing different things and rendering and be prepared for that. That's the first composable. And let's see a few alternatives that we'll have to create those stateless declarative UIs and why, trying to solve this question of why this is stateless. So I removed this stateful handler and I created something probably more simple. It's called UI state handler. You will see the difference in a sec, and we'll handle those UI states in the same way to render the declarative UIs. And of course, this is going to be exactly the same, but changing one entity with one another. Again, doing composition over inheritance and removing the state handler, adding the search UI state handler. And with that, passing the compose view as we already did, and just having the reference with the Stateful, and we don't have to pass any reference from the fragment as we did before. So that means we have the Stateful there. And now I don't need to pass the UI state in the states UI functionality, the composable, because into that one, I have already my Stateful that by means of this convenient functionality that is provided for Stateful, that is called collect as state, it will provide a state that is ready for composables to be processed. This is coming from the library, of course, from Jetpack Compose. And this state gonna have our values to be passed and be processed at due time every composition that we use and have. So, yep, now we are going to render this stateless UI. And what we have for a stateless UI is basically passing the UI state. We're gonna process the first one, list results UI state, by rendering a tweets grid. This grid is being composed by a collection of tweets. Inside this grid, I have a vertical grid with a maximum of weight, a combination of different columns or cells. This can be also adaptive, and this is actually it's not a stable version. So basically, this will change in the future, but you can imagine a combination of cells and then a collection of items. The count gonna be the number of items that you can imagine, and the item content with the trailing lambda gonna contain the tweets that we're gonna get the index from, and then we'll pass for this particular index that we are using right now, the tweet, and I will start creating the different items for every one of the cells. I created something called tweet box, that is a custom declarative UI that contains a tweet, and also on tweet click. That basically, as you can imagine, is a function. So we are passing here a higher order function. What we have into this higher order function is just like we are passing this. That is another function, simply returning a lambda that is getting us to the detail of the tweet. Nothing else. We are navigating to that, and we are passing the lambda to be processed. Right. So the tweet box gonna create a box that contains the on click that we pass by means of this higher order function, and then the box is containing this particular setup with the alignment and everything like that. Into this box, I use a column. Here's where we can see the UI that I want to render. So this contains an image, separation, and a text. So the box contains a column. If you're familiar with Android, you will think like this is equivalent to the linear layout. Exactly the same, we use a column here. And the first element that we use is actually the image. So the image is containing the URL, because probably we don't want for every composition to load again the URL and then loading the image. We can just use the operator remember coil painter from the library, and this will keep for us the URL. Then also super interesting and important, content description, because we are developing for everyone and accessibility matters. We need to use content description all the time. please don't do the trick of using quote, and add some valuable information for our users. Now, for this variation, we need a spacer with a height, and then the center text. That is just something that we want to render for the username to be shown. And with that, we have the box with the column and the image, the spacer, and the text. Now, for processing the rest of the items, I just created so I extracted the string from those for the file of different strings, and I rendered the same with the same component that I used to center text for the error and also for the empty UI state. Right, so this element can be reused very easily, and it's as simple as just having a text message and modify it with the padding, the style of it, and the overflow. You want to have an ellipsis or something like that. Then for the latest item, it's actually the same. So the other UI state is basically a top text. And just to finish, cleaning up resources. So you have any UIs, remember to put all to nullable, otherwise you will have memory leaks. Canceling different scopes, also to avoid memory leaks, and also to run startup concurrency and make sure that everything is canceled on due time. Destroying the views, again, the same, destroying different views. We don't want any view to be living after destroying our views. So when destroying the views, canceling all the different things and destroying the different views that we have. And with that, we have this ready with the Unidirectional Data Flow and the Declarative UIs being there. Something like that. Start typing is the top text that I showed you earlier. I am typing something here, so you can see this is working with the different elements that I already created. This is the different boxes that I created with the 3 different elements. Going to the next screen, and yep, that's basically it with Compose. Now let's see the probably most interesting bit of this presentation. Hopefully you are still awake there. Interoperability. Why this is good for us and is very interesting in Compose in particular. So I don't need to tell you what Compose view is because you already saw it during this presentation. But the good thing here is like we could go both ways. So you have all kind of application, and you want to start with from some point. You can use Compose view for that. On the other way, you have a new screen. You want to start from scratch and you want to use Compose directly, you can do that. And maybe you want to reuse a super custom view that you created that is super complex or has a video player that is complex to reproduce and create in Compose. You can use Android view and use the same. So Compose is really prepared to start interoperating between the different worlds, the imperative and the declarative world. Also, recomposition runs multiple times, and that means that we need to make sure that our views are prepared for the states as a single entity. Because if we rely in different orders of operations, then probably you will have a bad time sometimes. You wouldn't know what is going on and why. Then remember, we'll save our previous state in the view, because thinking in the case that I mentioned earlier, maybe you don't want to load an image over and over. You just want to do that when the URL has changed. And for that, remember, we will save you some time and resources. Then another very interesting concept is called composition local. That basically is the simplest way to pass data flows to the tree and its children. So what does it really mean, this kind of definition? So let's think right now that if you remember what this presentation tells you, we are starting a composable from a theme, and then we have a first composable. Then you want to create different entities by means of these composables. So you're creating, let's say in this tree, in this also called slot table, a tree with different elements. So you want to pass something in one of the branches, in one of the leaves, to go to this leaf over here. Then you need to pass this by means of the function from the top one to this one, if you want to apply this to this particular one. And to do that, you have 2 ways. Do it manually or using composition local. So basically, composition local is the way for you to use dependency injection without exposing a value through the whole tree. directly to the one that you needed. Then avoiding also using this value in recomposition for the different elements of the tree. Also, composables should be side effects free. What does it mean that? Thinking in side effects, a side effect is something as simple as requesting something to the network, doing a DB operation. So a composable is a UI. UI normally runs in the main thread, and side effects should run into a background thread. Otherwise, you will block your UI, so don't do that. So that means that you want to run side effects. You could do that, but then you need to use something called effects handler that is provided by Compose as well. It's a tool that anything that happens after recomposition can be run there, only after recomposition. And there is a lot of documentation. So the resources from Google are great on that. So just have a look and you'll see what you can do there. Also, Unidirectional Data Flow likes states, but really likes states. That means that you better are ready for states, or you're going to have a bad time trying to render your declarative UIs. Then thinking in imperative against declarative programming, this is a very interesting kind of mindset changing, because we come from a world where we need to set a visibility, enabling something, disable something, hiding this, hiding that. And now we don't care about it anymore. We just have it or we don't have it. What does it mean? Declarative UIs don't need to care about this is visible or not. They just need to care because we use the slope table or a tree, that anything that you want to render is in the tree at the time you want to render it. So when we want to render this particular grid that I showed you today, then you need to render this into the tree, nothing else. But then after all of this, why Compose? If we were so happy rendering massive layouts, creating endless files with 1,000 lines of custom views, which is beautiful. So if we think about it, so different pros and cons, Compose runs in parallel and very frequently. So that means that it's meant to be really, really performant. And this is gonna save you some resources as well. I'm gonna be very fast. So it's convenient long term. Also, the classic views can run in sequential order. So if you need to rely in a particular order to render a particular view, you can do it with classic views, but you cannot do it with Compose. Think about it. Compose is stateless. That means that don't care about states, but cares about immutable data. That means that by having immutable data, we can actually make sure that everything is deterministic and we can predict what we have into our Compose views. Classic views are stateful. So that means that everything can change. You need to handle probably different states from different views. And let's think in something big. Let's think in a XML layout where you have a ton of lines, custom view, different switches, and at some point, some of the switches change. In the other view, also something change. And then you need to make sure that everything is combined. How will you do that? Because from the top to bottom, probably you cannot really control it. Or you have an orchestrator that is having endless operators to control everything, which can be a bit harder to manipulate. So this is manipulation, and that means mutation. It mutates, you cannot predict it. So you don't really have a way to know what is going on there into this massive view because it has mutated. Then Compose only runs in Kotlin. So better be migrating everything if you have still Java files. Classic views, on the other side, they can use Java or Kotlin files. Obviously, because classic views belong to the OS of Android. So for sure won't be removed, but yeah. Now, thinking about different improvements, performance improvements is something that Compose really achieves. So basically, we're going to have parallelization in the rendering, in the UIs, and it is meant to be really, really fast. Now it's already fast, but in the future, probably going to be even better. So we'll see. testability, because by using Compose, we are going to make sure that everything is tested, because if everything going to be immutable by default and deterministic by default, that means that you can actually test every single layer. And when you arrive to your composables, you're going to know that everything was tested. So you can actually make screenshot testing for your UIs or specialized testing for also your UIs, and the rest should be properly tested if you want to. Reusability of UI components, because you can create very generic components in Compose and can be very easily extended and added to the stack. This with imperative UIs was super difficult to achieve. So this is a great advantage of Compose, actually. With very little lines, you have many generic things that you can create. And then finally, for me, experimentation of new ways of working. Because if we want at some point to render a particular UI into your app, your backend can just tell you, I want for this screen, this in that way. And you can render this super easy, because you're going to have instructions and you can just make sure that the UI is printing this as you go. Of course, this with imperative UIs could be achieved as well. But the way to do that, it wouldn't be so easy, to be honest. And then just to finish this presentation, next steps. Start adopting explicit state declarations today. Otherwise, when next month happens and Google releases Jetpack Compose officially with the first release candidate, you will be in a rush to remove and change everything to state declarations. So yeah, that's basically it for today. Also, I have some articles that I wrote, so you want to read more. The first 3 ones are about this presentation, but in more detail. And also speaking about Stateful, the 2 of the series plus this latest one that is a separate one speaks a bit further about Stateful. Also, special thanks to Nick Butcher, who reviewed those slides back in January. Now the presentation has evolved and have a few changes, of course, and updates. Thank you to you, and thank you for inviting me today to Brighton Kotlin. And if you have any questions, now is the time for questions.
Wow, thank you for that. That was amazing. We've got a couple of questions in the chat, and just to kind of follow on from the links to the articles, I posted a link to your site in the chat, so people can go directly there if that's where the articles are. So in the chat, we've got in the Compose documentation suggests to avoid architecture patterns like MVP. What do you think about that?
Yeah, 1 second. Let me drink some water.
So yeah, in the Compose documentation, it suggests to avoid architecture patterns like MVP. What do you think about that?
Yeah. This is not actually the first time that I received this question, so I know already the answer. Yeah, well, 2 things here. First of all, I kind of agree, like MVP maybe is not the ideal scenario to use Compose, but at the same time, maybe MVVM isn't either. What I mean here, using Compose and using Unidirectional Data Flow is how you do things more than what architecture you use. Also, if we think about MVVM, that is the existing pattern that Google recommends, in a way, this is recommended because the view models and the things that Google created are under MVVM. If they will still keep the, let's say, a use case they want to use, it's going to be equivalent to the view model. So in a sense, it's similar. If you remove the placenta and you have the view model instead of the interactor use case, it's the same. So yeah, don't use it because you can use something else. But if I was you, I will use maybe MVI, which is the best pattern to have unidirectional data flow. Really, a bit more complicated. You need to do more things like reducing states and everything like that. But it's up to everyone. And the unidirectional data flow can be just basically done and manipulated in a way that you can do as you prefer, basically.
Okay. It might be the same for this question as well, but what would be the major benefit of using Stateful instead of live data?
Yeah, except the initial state. So the main benefit, first of all, is like with the Stateful, Google won't deprecate live data. That's the good thing. When live data gonna be deprecated, you're gonna be safe because you've already migrated. That's the first thing. They promise they won't remove and deprecate live data. But we know Google. If you trust Google, up to you. Other than that, you can do everything that you do with live data in Stateful. And even more now that they created a few helpers for the different lifecycle architecture components and everything, where you can use and you can stop Stateful in the background with those helpers that they created. So you can say exactly the same. The thing is like dev data is something that was created for facilitating work on Android. To be honest, I never used live data myself. I know about live data because I did a few presentations last years and I had to investigate it myself. So it doesn't really give any advantage compared to Stateful, and Stateful can do those things plus more things. If you need only the use case for the live data, then it's fine. Also, live data is very prone to errors because it runs in the UI thread. So if you need to do something in the background thread, you're going to have about time, you're going to block your UI. So you're going to have more drawbacks than benefits. So I don't see a clear advantage of using live data, but convenience and don't want to adopt anything new.
Excellent. Thank you, Raul. I really appreciate your time. I think that's it for the questions. It's been an absolute kind of bumper session tonight. So thank you for staying with us. I'll just quickly share my screen. Hopefully you can see the up and coming events from Silicon Brighton. We've got PHP Sussex on the 29th, Brighton Pi on the 8th of July, and Brighton Gophers on the 27th of July. Also, I shall quickly throw into the chat the link to the next Brighton Kotlin meetup, which is, we've got one speaker so far, and that's on functional programming with Arrow, so that should be pretty interesting. Thanks to all our speakers tonight. Really appreciate your time.